Hello everyone. Today our topic is electrochemistry. Today we shall learn how to solve or how to find the EMF of the cell or the standard electrode potential of a cell. So the first formula we have in order to find the EMF of a cell is E naught cell equal to E naught cathode minus E naught anode. So E naught cell is equal to E naught cathode minus E naught anode. Or we can also write E right minus E left or E naught reduction minus E naught oxidation. So basically we use these two formulas in order to solve E naught cell. We can also use this formula while the cell reaction is given. So here is our first question and we shall solve this question using the above formula. So calculate the EMF of the following cell at 25 degrees Celsius. Cr3 plus, the concentration is given, Fe2 plus, concentration is given again, Fe, where E naught Cr3 plus Cr is minus 0.74 volt and E naught Fe2 plus by Fe is minus 0.44 volt. So now I'll just write down the given. We have Cr3 plus. Since we are in no use of this concentration, so I'll not write the concentration. We don't need the concentration in order to find the EMF of cell. So here is the given. So now if you look this one carefully, so this side will be your A, this side will be your C, or you can do A, this will be your B, and this will be your C, this will be your bridge. So A, B, C. A is anode, B is bridge, and C is cathode. This will be your cathode, this will be your anode. Or you can write, this side is on your right side, so you can write R. This side is on your left side, so this will be your L. So what is the formula? E naught cell is equal to E right minus E left. So using this formula also we can write, so what is on your right side? This one. So you can write E naught Fe 2 plus by Fe minus E naught Cr 3 plus by Cr. So now you can write down the values. So the values of Fe 2 plus is minus 0.44 volt minus 0.74 volt. So minus 0.44 volt plus 0.74 volt. So you shall have 0.30 volt. So this will be your answer. So E naught cells go to 0.30 volt. So easily you can know which one is your right side and which one is your left side. So this will be your cathode, this will be your anode. Or else you can write out here E naught cathode minus E naught anode as well. So easily you can solve the standard electrode potential. Okay, let's try. Okay, now we shall try our next problem. So I've written down the reaction out here. I haven't mentioned the concentration since we're in no need of the concentration to find E naught cell. So now in this reaction, if you look at the reaction carefully, so it is a cell reaction, and so we cannot use E right minus E left out here, and we don't know which one is cathode and which one is anode. So now the logic we are going to use here is E reduction minus E naught oxidation. So what is reduction? Reduction is gain of electron. So if you look here properly, Cu2 plus, so there is loss of 2 electrons and out here it is CO0. So there is gain of electrons out here. So this will be your reduction. And what is oxidation? Oxidation is loss of electron. So out here is Mg0 and out here we have Mg2 plus. So there is loss of electrons. So this will be our oxidation. So now I can write E naught cell is equal to E naught cathode minus E naught anode. So I know which one is cathode and which one is anode based on reduction and oxidation. So I can write E naught Cu2 plus by Cu minus E naught Mg2 plus by Mg, reduction, oxidation. So here are the values. Cu2 plus is 0.34 and minus 2.37 volt. So now you have 0.34 plus 2.37. So your values would be 2.71 volt. So your E naught cell will be 2.71. So here the formula I'm using is E naught reduction minus E naught oxidation. I hope you understand the problem. So now again we shall try our next problem. Out here we shall use NERNST equation. So represent the cell in which of the following reaction take place. Mg plus 2Ag plus 0.001 molar concentration, that gives Mg2 plus 0.130 molar concentration plus 2Ag. Calculate its E, it means E cell. If E naught cell is 3.17. So first I'll write the cell reaction. So you have Mg plus 2Ag plus 0.0001 concentration, that give Mg2 plus 0.130 plus 2Ag. So out here if you look carefully, this is 2 plus and out here this is plus. So in order to balance the oxidation number, we put 2 out here. Since when I put 2 out here, this will also be 2 plus and this is also 2 plus now. And out here this is plus 2Ag. Since I put here 2, I also need to put here 2. So now using the NERNST equation, I can write E cell is equal to E naught cell minus 0.059 by N log, it is log Q, but we can write log Q is equal to concentration of product. So out here this side will be a reactant, this side will be a product. So out here Mg2 plus concentration of product divided by concentration of reactant. These 2 out here, you're going to write this one as power out here. Whatever number is out here before, you're going to write it as power. Always remember. So now I'll put down the values. So you have E cell is equal to 3.17 as given in the equation, minus 0.059. So N out here is the electrons. So out here this is 2 plus, and since this one also will make it as 2 plus, so N will be 2. Log Mg2 plus is 0.130 and out here is 0.0001 whole thing square. So E cell is equal to 3.17 minus, if you divide 0.059 by 2, you get 0.0295 log 0.130 0.0001 multiplied by 0.0001. E cell is equal to 3.17 minus 0.0295 log. So if you remove the point, you have 130 into 1, 2, 3, 4, 5, 6, 7, 8. So I get 10 to the power 8, and 1 into 1 is 1 into 1, 2, 3. I get 10 to the power 3. So this one I can cancel 3. If I cancel from here, I'll have 5. It will be log 130 into log 10 to the power 5. So now, if you calculate the log, you will get 7.1139. So now, if you multiply these two numbers out here, you will get 3.17 minus 0.209. So E cell will be 2.96 volt. So our E cell will be 2.96 volts. So this is how you're going to calculate E cell. I hope you know how to take the log carefully. If you know how to take the log, it will be quite simple for you. So let's try our next problem out here. I'll just write down the givens. So here is the given. So calculate the standard electrode potential of Ni2 plus by Ni standard. Whenever it says standard, it will be E naught. So E naught Ni2 plus by Ni. So this is what you're going to calculate. So in order to calculate this one, what do you need? You need E naught cell. If you don't have E naught cell, you cannot calculate this one. So if you look out here, if the cell potential of the cell, it doesn't mention standard. So if the cell potential of the cell is 0.59, if the cell potential of the cell is 0.59, so that means E cell is equal to 0.59 volt. So these are all the givens. So first, let's write the cell reaction. So whenever you write the cell reaction, remember how to write the cell reaction. So this one, out here this will be 1, I'll take this one as 1, this one as 2, this one as 2. I'll write 1 and 1 together and then 2 and 2 together. So Ni plus Cu2 plus, that give Ni2 plus Cu. So this is how our 1 plus 1, 2 plus 2. So this is our cell reaction. Now using NERNST equation, we have E cell is equal to E naught cell minus 0.059 by 2 product by reactant. So this is our product by reactant. So E cell is 0.59 is equal to E naught cell minus 0.059 by, so this is our N, sorry. So and since this is 2 plus, N will be 2 log. So Ni2 plus, how much is Ni2 plus? Ni2 plus is 0.01. So out here 0.01 and Cu2 plus is 0.1. So if you remove the points, you'll get 1 by 10. If you divide by 2, you'll get 0.0295, and then out here log 1 minus log 10. 0.59 is equal to E naught cell. Log 1 is 0, log 10 is 1. So you'll have 0 minus 1. So 0.59 is equal to E naught cell plus 0.0295. Since out here if you multiply with 0, this will be 0. Again, if you multiply with 1, minus into minus will be plus. So E naught cell will be 0.59 minus 0.0295. So E naught cell will be 0.5605. So this will be your E naught cell. So now still we are not done. After this we have E naught cell is equal to E right minus E left. So E naught cell is equal to, what is our right out here? Our right is Cu2 plus by Cu minus E naught Ni2 plus by Ni. So now we are going to calculate this one. So this is given in the equation. Now we have calculated this one as well. So 0.5605 is equal to 0.34 minus E naught Ni2 plus by Ni. So E naught Ni2 plus by Ni will be 0.34 minus 0.5605. So if you subtract these two numbers, you will get minus 0.2205. So this is how you get E naught Ni2 plus by Ni, standard electrode potential of nickel 2 plus by nickel. So in order to find this one, we need E naught cell. Since if you don't have these two values, we cannot calculate this one. So first I calculate E naught cell, and then I put both their values, and then I get E naught Ni2 plus by Ni. So the most important step is, first you need to know how to write the cell reaction, and next you use the NERNST equation, and then you can easily solve depending on whatever is given and what you're supposed to find. So now again, let's solve the next problem. Calculate E naught cell for the following: Cr, Cr3 plus, Fe2 plus, Fe. E cell is also given. So you're supposed to calculate E naught cell. So I'll just write down the given Cr3 plus 0.01, Fe2 plus 0.1 by Fe. E cell is equal to 0.261 volt. So this is given in the equation. You're supposed to calculate E naught cell. So what did I say? Our first step is to write the cell reaction. So this is your 1, this is your 1, this is your 2, this is your 2. Easy way to remember. Cr plus Fe2 plus, then give Cr3 plus Fe. So now if you look at the cell reaction carefully, you will see this is 3 plus and this is 2 plus. This is 2 plus and this is 3 plus, so I need to balance them. So what number should I put so that they can both be balanced? So this is 2 plus, so if I put here 3, 3, 2 is 6, and I'll put here 2, 3, 2 will also be 6. Since I put 3 in front of Fe, I'll put here 3. Since I put here 2 in chromium, I'll also put here 2. So now 3, 2 is 6, 3, 2 is 6. So N will be how much? 6. So now using the NERNST equation, I can write E cell is equal to E naught cell minus 0.059 by 2 log product by reactant Cr3 plus. This is your product and your reactant is Fe2 plus. So before Cr I'm putting 2 out here, so I'll put here 2 to the power 2, and since out here there is 3, I'll put here 3 as well. So E cell is 0.261 equal to E naught cell minus 0.059. So this is N. So out here what is the value of N? 3, 2 is 6, 3, 2 is 6. So N will be 6 log. What is Cr3 plus? So if you look here out here, Cr3 plus, concentration of Cr3 plus is 0.01, Fe2 plus is 0.01. Both of them are same. So 0.01 whole thing square, and out here 0.01 whole thing cube. So 2.261 is equal to E naught cell minus 0.059 by 6 log 0.01 into 0.01. 0.01 to 0.01 into 0.01. So now if you remove the point, you have log 100. I'll just write here again. So log 100 is 2. So 0.261 is equal to E naught cell minus so our E naught cell will be 0.28 volt. So this will be our E naught cell. So this is how we can calculate E naught cell after balancing the cell reaction. So now we are at our last problem. So out here is the equation. The EMF of the cell is given out here, has been found to be 0.3305. So it doesn't mention standard. So it has just said EMF. So this will be our E cell at 298 Kelvin. Calculate the value of M1. So out here they haven't given the concentration of CD cadmium. So we are supposed to find the concentration of cadmium. E naught Zn2 plus by Zn is given, and cadmium 2 plus by cadmium is also given. So whenever these two is given, always remember first we can find E naught cell. So out here I've written down the equation. We are supposed to find this M1 out here. So solution, cell reaction, Zn. So after writing the cell reaction, we can find E naught cell equal to E naught right minus E naught left. So which one is on the right side? Cadmium is on the right side. This is on the left side. 2 plus by CD minus E naught Zn 2 plus by Zn. So we have 0.36 volt. Our E naught cell will be 0.36 volt. So now we shall find the concentration of cadmium. So first we shall write the NERNST equation. E cell is equal to E naught cell minus 0.059 by N log Zn2 plus by Cd2 plus. In the cell reaction, if you look, both of them are 2 plus. So our N will be 2 plus. E cell is equal to E naught cell. Our E naught cell is 0.36 minus 0.059 by N, by 2 log Zn2 plus is 0.1 by M1. Our E cell is also given. Our E cell is 0.3305. 0.3305 is equal to 0.36 minus, if I divide this one, I'll get 0.0295 log 0.1 by M1. I hope till here you don't face any problem. So now I shall move this one this side, or I can move this entire this side, and I can move this one this side as well. So I have 0.0295 log 0.1 by M1 is equal to 0.36 minus 0.3305. 0.0295 log 0.1 by M1 is equal to 0.0295. Log 0.1 since both of them are so I need to divide. I just move this one down here so I can cancel both of them. Log 0.1 minus log M1 to 1. So log 0.1 is minus 1 minus log M1 is equal to 1. So I can write here log m1 is equal to minus 2. I will move the sign that side. So whenever it is negative antilog, we need to do step 1 and step 2. So m1 will be antilog of minus 2. So m1 is equal to. So now when we do step 1 and step 2. So in step 1, since it is negative, I need to convert it into positive. So step 1, 1 minus 0.000. So I'll get 1. And then step 2, 1 plus 2, that will be 3. So now I'm going to take antilog of 1. Antilog of 1 is 10. So this 3 I can write into 10, since it is negative, into 10 minus 3. So m1 will be 0.01 molar. So this will be our concentration. So in this problem, what did I do out here? So log, since this is a and b, I can take it as a and b. So whenever there is log numerator and denominator, we need to do log numerator minus log denominator. So if I take it as a and b, log a minus log b. And then this one, I move it down here, so I cancel both of them, I get 1. Log 0.1 minus log m1. So log 0.1 minus log m1 is equal to 1. So log 0.1 is minus 1. So this minus 1, if I move this side, it will be plus 1. 1 plus 1 is 2. Minus, this minus, I move it this side. So I get log m1 is equal to minus 2. So m1 is equal to log, if I go that side, antilog minus 2. So antilog of minus 2. So whenever it is negative, we need to convert it into positive. So using step 1 and step 2, when I take antilog of this one, I get 10 into 10 to the power minus 3. Which one I can, this I can write it as 0.01 molar. So this will be our concentration. This is how you calculate the concentration. So by this, we finish some numerical problems from electrochemistry. So if you face any problem, you please let me know in the comment section.